Hello and welcome to the NAB 2020 Overview and Technology Highlights. I'm Mike Callahan, Head of Media Solutions Marketing with AWS, and this is Kevin Moore, Director of Product Management, leading up a lot of the live video solutions with AWS Elemental as well.
Hello.
And throughout this presentation, we're going to cover a lot of the work that AWS has been doing coming into the spring of 2020. Included in that are a lot of live video workloads that Kevin is going to really deep dive on. So we'll start with our set of themes that we're going to talk about today. They kind of blend through this idea of AWS and how we are going to approach the media space, and they kind of wrap up at the end with some service launch announcements. So we'll go through this full set as we go through today. But we're going to begin by doing a little bit of a recap around what does AWS look at when it's considering the media workloads. And we really look at from the very beginning of where content's created all the way through to content distribution, along with everything that happens in the middle. The media supply chain, machine learning, analytics, how you're keeping track of your content as you go through.
That really is the life cycle, isn't it, Mike? Everything from the camera to the display device. What would you say are the companies that have really shown success in all of these different areas recently and talked publicly about their success on AWS?
Yeah, probably our biggest set of success stories recently have come out of reInvent. And across the full reInvent, across the full spectrum, we talked with customers like Turner, who were spending a lot of time doing remote workstations and learning how they could do their production remotely. Untold Studios is one of the first creative studios in the cloud. They are, again, like similar to Turner, have spent a lot of time figuring out how they can use their people resources wherever they're at in the world, while using the power of the cloud to tie all of their projects together. With the media supply chain and asset management, Rock and Roll Hall of Fame has spent a lot of time learning how they can check and analyze their full content library to look for specific artists or equipment or whatever it happens to be that they're being asked to provide by their constituents. And then in the distribution side, Fox announced a bit about their broadcast plans, and Kevin will go into more details about that as we talk through this presentation today. But we also have had Hotstar talking about IPL and how they were able to kind of set world records with their number of people viewing their live streams. HBO talked a lot about their play out in the cloud, and Eurosport talked about play out in the cloud for the work that they've been doing, but it also expanded into how they can reuse that same type of workflows in order to be able to build new technology and new products much more quickly. So one of their main examples was Food Network Kitchen, which they were able to launch within around 10 weeks by using the same type of infrastructure that they'd built for the Eurosport workflows.
You can really see here how AWS is solving problems at really every step of the chain. You've got how can I use the cloud so that I can make more and better content at less cost? You have that middle step where you say, I've got all this content, I've got content going back decades in some cases, how do I get more value out of it? And then you have the third problem that every media and entertainment customer has, which is how do I distribute this content to my end customer who wants to appreciate all the hard work that we did creating this stuff? So it's really great to see AWS kind of solving those problems across the board.
That's exactly right, and that's why our first theme here is that AWS is the place for media, and within those set of workflows, we're able to show that full pipeline. And this is just a small example of companies that are doing kind of these innovative work across the media pipeline.
Well, so that's all well and good, but what would you say is the one thing that's new in 2020 that shows that continuing momentum of AWS, continuing to solve problems and be recognized as a leader in media and entertainment? Yeah. New this year.
Funny you should ask. So within this year, we've announced that there is a technical Emmy Award, a technical and Technology and Engineering Emmy Award that has been given to a combination of 5 companies. So that is Evertz, AWS, SDVI, Walt Disney Television, and Discovery. And this work is kind of a culmination of work that AWS has done with Evertz and work that AWS has done with SDVI, as well as those companies working with Walt Disney and Discovery. So what we were able to prove is that the cloud is a viable option for these media supply chains for content ingest, management, and delivery. And that's essentially what the award was given for, pioneering public cloud-based media supply chain for content ingest, management, and delivery. That side of it is really one of the main keys to building out your workflows across any platform, and we're showing how you can do that within a public cloud.
That's amazing.
Along with that technical Emmy, the technology Emmy, there is a set of partners that we were talking with about being on the AWS stand at NAB as well. And one of the things that I think is most interesting about this is how things have shifted a little bit over time. When we look back 3 or 4 years ago, what we really saw was a lot of partners on the content distribution, maybe content distribution and supply chain sides. But what we're really seeing right now is that a lot of these workflows that partners are involved in are actually moving back closer and closer to where the content is being created. So we're seeing this kind of pull back through content creation, whereas previously it had been more limited on the content distribution side. And this is a big shift that we're seeing in the market, and it's really helping flesh out the full set of workflows that are possible within AWS. And here's a set of companies that are helping make that happen. So this will actually lead into our next themes. Our next couple of themes are really spend a lot of time talking about how you can move this workload back closer to where the content is being created. And that's really what our theme 2, bringing the cloud closer to you, emphasizes. So AWS has a set of services and capabilities that really help allow you to launch your products and services from the creation part of your product workloads all the way through.
And what are the sort of new releases that kind of best help the cloud get closer to you? Kind of seems like the cloud has always been sort of far away, but that story is kind of changing a little bit. Isn't it?
It's starting to change, and that's why we're talking about these three new services: AWS Local Zones, AWS Outposts, and AWS Wavelength. So these 3 services are 3 of the 5 that we'll talk about in this theme area that really help enable you to create content more close to where your artists and production teams are.
So what is an AWS Local Zone?
So AWS Local Zone is very similar to it's very similar to an AWS region. It's really a branch of an AWS region at the end of the day.
Okay.
And what we see people using the local zones for, so in this case, it's really meant to give you a low latency capability that's much closer to where you're creating the content, to have a low latency access to the AWS to an AWS data center. And what we expect to, and what we've seen people doing with these local zones is things like remote workstations for VFX and for editing, and doing things like broadcast production with your switching, which is something that has to be done in very low latency. So those are a couple of examples of things that customers have been looking at local zones to do.
I get to use all the same AWS APIs, but the resources I'm controlling are now a lot closer to me.
Exactly. That's exactly right.
Awesome.
So everything moves closer to you. So you can do these workloads that are really latency dependent.
So that might be in my city, a local zone.
Yep.
What if I wanted to get AWS resources even closer, say in my building?
Yeah. So for that one, that's where we have AWS Outposts. So AWS Outposts is really bringing a rack of AWS product into your data center. So this is a case where We have one more slide where we can actually show what this looks like coming up. But this is a product where we expect customers are going to be able to do things like production that they wouldn't have been able to do in the cloud, but they can do locally. They can do things like live play analytics or on-set venue, kind of a replacement for on-set venue infrastructure that they would have done previously.
And again, it's those same APIs. So I built an application, I run it in a region today.
Exactly.
Now I can run it in my data center.
Exactly.
Wow, that's amazing.
And the last piece of that is in the world of media workloads, there are still a lot of custom hardware solutions. And so this is a way that you can get your custom hardware solution and AWS on your network, essentially, so that you aren't trying to send data very far, and you can keep these really low latency applications whole.
Got it. Well, so that solves how we get the sort of AWS capabilities closer to the content owner. But the content owner has customers, and a lot of those customers are on mobile devices. So what are we doing to help them get closer to their mobile customers?
Yeah. For mobile customers, we have AWS Wavelength. So AWS Wavelength is putting something very similar to Outposts, but into the carrier network. So that inside the carrier network, you can really quickly respond to data requests from customers. So if you have a customer that has an application that is based off of, say, a sports venue, and they're doing analytics or something like that, and you want to be able to give them the absolute lowest latency path to getting content, they can use Wavelength to run those analytics. And the same thing for machine learning. This is a way to run machine learning inferences or machine learning instances kind of as close to the customer as possible.
Amazing. Wow, those are great capabilities. I guess the cloud's not as far away as people think, and it's getting closer all the time.
Getting closer. Yeah, it's getting much closer. And
wow,
in this case,
what is this?
This is what the AWS Outpost rack actually looks like. So it's a standard 42U rack. It comes fully assembled, rolled into your data center, and ready to connect power and networking with everything that you would expect, like redundant active components and so on.
And this is the same hardware that AWS runs in the data center?
This is, I don't know if it's the same. It's very similar.
Well, that is incredible. All under the same API.
Yeah, that's the key. The real key of all of this is that you're able to reuse the work that you would have done within the AWS data center, but you're doing it within your own network in your own data center.
Awesome.
That's the big difference. The last piece around pulling content closer to the user is virtual workstations and also rendering on AWS. So the virtual workstations piece has been really important as I mentioned with the Turner example. They find this, and same thing with Untold Studios, they use these capabilities to run the same tools and systems that they would run in the on their premises. They're running them remotely within the AWS data center. And as they're running things within the AWS data center, they're able to take that content that's being created and built and move that to the next stage without having to leave AWS or without having to transfer data back and forth. It helps keep everything all in one place and makes their workflows more efficient, which leads into the rendering on AWS piece.
Wow, it seems like the virtual workstations and the editing workflow really helps break you out of that old world where you're scheduling edit bay time in Excel and trying to balance, and people are staying late and coming in early just to get machine time.
Yeah, and
huge benefit.
People are able to log into their remote workstations from other places in the world. They don't have to be in the office anymore. That gives you a lot of capability to look at using different artists or different content creators or work from home if needed.
That's right.
And then rendering on AWS is really about how do we take advantage of the large number of compute instances that are available at any one time so that you can, if needed, spin up a new project or rerun a project. There were a couple of movies not that long ago that had to redo a lot of their video graphics effects. And being able to do that type of work in the cloud without having to buy more equipment or without having to offset your existing projects or interfere with any of your other business is a gigantic benefit.
Yeah, that ThinkBox team has done so much great work for the rendering use case on AWS. Just a great product.
It is very amazing the things that can be done now. I'm going to hand off to you, Kevin, and have you kind of lead us through the next couple of sections. The first one is broadcast moving to the cloud, and of course the Fox announcement is probably the biggest piece of this. But really, what it is we see this shift. We've seen it in OTT previously, and now we're starting to see it across other areas of the workflows, and broadcast is one of those.
Sure. Thanks, Mike. So broadcast moves to the cloud. What are we talking about when we say broadcast moves to the cloud? So OTT-based solutions. So what is OTT and what is broadcast? OTT stands for over the top. It's basically delivering video by using the internet and internet protocols and CDNs directly to the home. And then there was this older style, which is still called broadcast, and that's basically delivering content either over the air or delivering it to what are called service providers. So this could be cable companies or DTH companies and things like that. So it's essentially the part that's non-OTT. And what we're really starting to see is that the broadcasters, who are all quite famous in their countries and very well-known names, are coming to us and saying, we want to modernize not just our internet delivery systems, but also our traditional broadcast. We're going to keep delivering content in that way on those traditional channels, whether over the air or through cable service providers or whomever. But it's really important to us that we modernize the workflow that gets that content done. And a great partner that has really kind of stepped out boldly and shifted their plans to do this on AWS is, of course, Fox. So Fox made a big announcement last year at the reInvent time period that they're all in on the AWS cloud and that they're using it for cable and satellite broadcasts. So it's that traditional broadcast workflow. Fox is doing incredible things in OTT. They're going to continue doing incredible things in OTT, but they're also making migrations of their cable and satellite broadcast workflow to also run on the AWS cloud.
Yeah,
so
and they came with, they said they had a set of challenges. They have a little bit of a unique scenario compared to most broadcasters with the acquisitions that have taken place, but they still came with a set of challenges that were the same for everybody. How do you make your content more accessible? How do you work through changes that are happening in the market and react more quickly? All of these pieces that we've kind of proven through other business flows that the cloud can help solve those challenges.
Absolutely. And it's worth pointing out this call out here at the bottom of the screen. Not only did they like what AWS provided for this broadcast distribution workload, but also some of the improvements that Mike just talked about, such as local zones and things like that, were really meaningful to this customer for purposes of future editing workflows and things like that. So AWS local zone in particular was hugely beneficial and influential for this customer. Okay, so generalizing a bit, what are we talking about? How does live broadcast work? It's very simple. We've put it all up on the screen. Okay, that's a joke. It's actually not super simple. An enormous amount of effort goes into it. Typically, every broadcast that we see in our homes is a combination of sort of live and pre-recorded content. Even a major sporting event is cutting between live content on the field and pre-recorded content in the form of commercials or other forms of interstitial content. So there's a huge amount of work done on site, often in the form of these really cool mobile trucks, which are these television studios on wheels that roll up to the venue for game day, and then a signal is distributed to the cloud. A signal is distributed to what's called the broadcast center. So the left part of the diagram there represents what we call the event site or the venue, and the right side represents the broadcast center. And there's always a sort of link, usually delivered over satellite or sometimes terrestrially or sometimes both. And that's sort of the division of responsibilities there. Now, in the broadcast center, you'll have a studio similar to the one that Mike and I are sitting in now, although probably even more advanced. And that studio content will be run through what's called a production control room. And so that's actually making the decisions. When do we take the field? When do we roll what's on disk in the form of commercial? And when do we cut to the studio? And then all of those signals are sent to a kind of infrastructural layer where processing and routing is done, and the final program assembly is done, and what's called the linear feed. So moment by moment, what content is being shown, and then that signal is encoded and distributed. And as we really looked at this problem, and we talked with our customers, Fox and others, about how we were going to help them on this migration to the cloud, it became very clear that the first thing that we would solve was actually at the right-hand part of the diagram. We would essentially work from right to left. So we're going to kind of zero in on this right-hand side here. So this is encoding and what's called multiplexing, and then distribution. So what we did at AWS is so in this diagram, I'm basically just taking this diagram and we're zooming in on that green box here. So what we did is we outlined a very ambitious set of capabilities in MediaLive that we then worked very diligently on and delivered last year. So AWS Elemental MediaLive is our live transcoding service. So it's not a software image, it's not an AMI. You don't manage the infrastructure, we manage it for you. And that allows us to give you the greatest level of resiliency and reliability. It allows the customer to focus on their content and their operations, and not doing a lot of sort of low-level IT management, provisioning, patching, networking, things like that. So what we did is we added capabilities into MediaLive to make MediaLive basically have all the necessary capabilities and to do them very well for national distribution. And typically, when signals are distributed nationally from a broadcaster to a service provider, they're all bundled up into a large bundle, which is called a multiplex. And so within that multiplex, there will be many individual channels, and those channels will share their bandwidth in a sort of, it's a name that just rolls off the tongue. It's called statistical multiplexing. And basically what it means is that a channel that is doing more challenging content is given more of the bits in that overall pipe, and a channel that is at that moment having less challenging content has fewer bits. So in this way, the picture quality is optimized because you want to spend your bits where the bits are going to do the most good. So all of the encoding processes are talking to each other and making collaboratively a decision about what's going to make all of the channels look the best. And this has been an absolute cornerstone of the satellite delivery market. And prior to the fourth quarter of last year, there was no service that provided this in the cloud. But just prior to reInvent, we launched StatMuxing for MediaLive, aimed squarely at this broadcast type of customer. A customer who wants to move play out to the cloud, a customer who wants to do distribution encoding in the cloud, a customer who wants to move as much of their operations to the cloud as possible, but still needs a statistically multiplexed signal for distribution to their partners. So you can see it here on this diagram. The diagram is a sort of left to right flow. So now the PCR still exists. The sort of linear playout is the linear content is still produced in the standard way. And then a contribution encoder is used to send signal to the cloud. And then MediaLive can encode it. And keep in mind, this is just the output of one production control room. A broadcaster typically has, several to many tens of channels, all running at the same time, and so those are all being encoded and all multiplexed together into one flow. That final output flow is called a multi-program transport stream, another name that just rolls off the tongue. And that multi-program transport stream is then returned to the customer premises and then can be sent over their existing satellite distribution chain to feed all of their distribution partners. So in this way, you can move not only the sort of newer OTT workloads to be powered directly from the cloud, but also the more traditional broadcast workloads directly from the cloud. And as we call out in the diagram, there's more. You can do additional things with those signals, such as attach, detailed analyzers, QC monitors, multi-viewer applications, so you can kind of keep an eye on everything that's going on in the cloud in the way that you can do on-prem today. So we feel like we've really created the essential elements necessary to do this core broadcast distribution workload in the cloud.
One of the things that I thought was kind of interesting was that when the MediaLive StatMux product was rolled out, we changed how our pricing models worked a little bit by expanding the time frame, right?
That's true. MediaLive has been traditionally priced on a per hour price and then on an annual reservation price. But in really talking with these customers and realizing, a broadcaster doesn't make decisions lightly. A broadcaster thinks in years or decades in terms of their investment. And they really become a fabric of the culture of the countries that they operate in. So it's not surprising that they do this. And what we realized is that it was very important that for StatMuxing product that we create pricing tiers that allowed customers to access even lower pricing if they made 3-year commitments or even beyond 3 years. And so if you look at that, you'll see that the MediaLive StatMuxing is priced at 1-year and 3-year commitment levels, as well as the sort of on-demand level. But the truth is a customer that uses StatMuxing and a broadcast distribution workflow is typically deploying a 24/7 environment because it's a lot of sort of capital investment to get these distribution channels set up to cover an entire continent. And once you've done that, you might as well put interesting content on there all day long. And you're probably planning to do it for many years. So we wanted to make sure to update our pricing to reflect the sorts of timeframes that our customers were thinking.
Yeah, it's meeting the customer need and customer requirement. And I think that is a little bit unusual within a lot of the work that AWS has generally done, and this is an area where we're actually pushing forward on media workloads in a kind of a unique way.
Yeah, absolutely. We're very pleased with the offering, and we're having a lot of exciting conversations with broadcasters, really the world over, about this capability and how it can help them modernize their operations while still serving their existing distribution channels.
Can you talk a little bit about more of the vision of kind of where AWS sees
absolutely so
broadcast going? So
we talked about a sort of right to left plan, that the first workload that it was important to move to the cloud with high reliability and deep focus was the encoding distribution workload. But if we look at this diagram here, which is a bit of a forward-looking, how will things go in the future? We think that we can bring more in. And so fundamentally what we have here, and this kind of, so what is going on here? So the difference between this diagram, which sort of represents the future that we're trying to build to, and the diagram that we showed before, is that production control room has really moved into the cloud. So we're in discussions with many partners who have great software solutions for these. We're leveraging our Direct Connect technology, which is sort of private networking to and from important venues. We're leveraging advanced codecs such as JPEG XS and new protocols such as SMPTE 2110. So we're really trying to build to that future where we can take the raw camera signals or a very light switching from the venue or from the studio. We can put it in the cloud. We can make those production level switching decisions in the cloud. We can do all the playout in the cloud. And once you have that, you've really lowered the capital requirements, which means you have simultaneously greatly increased the reach of the broadcaster. The amount of stuff that needs to be put in each venue greatly reduces. The amount of capital it requires to provision a studio or to be able to broadcast live out of a studio greatly decreases. And you can really get that flexibility. As Mike pointed out before, the editing workload is highly bursty, right? These projects have intense editing phases, and then they have phases where there's no editing at all. The same is true about live production. We have some customers who, are doing no live content for 20 hours out of the day, and then, 4 hours out of the day, they're doing a tremendous amount. Some, it's more of a balance, but the very workload of live production is highly bursty, and it's a great fit for the elasticity of the cloud. So we're excited to be rolling out a lot of these technologies here. And as you can see, this concept, so important we wrote it twice on the board, is latency reduction. So this is why we are investing so much in technologies such as low latency, FAR zones, direct connect.
The scale is just different on latency for these types of workloads than the ones that you walked through before, the OTT and distribution workflows. Right?
Absolutely. In distribution, you're trying to accomplish latencies in the single-digit number of seconds. You're doing quite well if you accomplish that. But in the world of production, you want to be driving it far below a second. You need very responsive. It needs to feel like you're there, pressing camera 1, camera 2. All of these things, super important.
Yes.
So
some of this is at its sub-frame latencies for requirements when you're switching between different types of contents, or you're watching an event and something unfolding and being able to switch really quickly. I mean, those are far less than a frame. That is as fast as you can push the button.
Absolutely, and so that's why we're using AWS local zone technology, direct connect technology, very low latency codecs such as JPEG XS. All of these things are key parts of the solution to enable that production control room in the cloud vision. And of course, once that is fully realized, then it all fits together with the distribution and coding in the cloud and so on and so forth. And it can really modernize the broadcaster workflow. So it's very exciting. It will be the project of multiple years, of course, as all good projects are. But we feel like we've made great progress, and there's more yet to come.
Awesome.
However, so we just talked about latency. But latency is not just a contribution problem. It is also a distribution problem. And we at AWS have made several advancements in that area recently. And we have some customer success stories that we'd like to talk about. So the distribution latency is important because viewers are more engaged when they have a sense that what they are watching is really happening now. And people consume information from many different sources now. They might be getting it in broadcast in one room of the house. They might be getting it in streaming in a different room of the house. They want those latencies to be the same and low. And they might also be getting information from social media or from their friends, text messages, whatever. And so it's very important that everyone worldwide, no matter how they're watching content, are watching it in a similar low latency experience on every platform.
As close as possible to the same time.
Yes. If Mike goes to a game and he's texting me what he's seeing and his reactions to that game from his seat courtside, which I know is where Mike sits, and I'm a minute behind, I'm not going to be happy about that. So it's very important that we can deliver technologies to get the latency low for all of our customers. Okay, so
how do we do that?
How do we do that? Well, so OTT kind of got a bad rap early on because OTT was initially designed to be very conservative. This was in a time when the internet did not work as well as it does today. Bandwidths were worse, connectivity were worse. Packet loss was higher. All of those things led to basically greater reliability. Mobile networks were terrible.
Way back, like 8 years ago.
Exactly, the dark ages of like 2012. But there has been enormous progress on all of those levels. Mobile technology, networking technology, backbone technology, player intelligence, whatever you want to call it. So this is just a little bit of a deep dive in how this works, this ultra low latency technology. So if you think about it, and this is very basic, I imagine most people in the audience know this, but when we watch a live stream on a device, what we're really doing is we're downloading lots of files, one after the other, after the other, after the other. And each file is between, say, 4 and 10 seconds long. Some of the early guidance at the dawn of OTT was to use 10-second segments. And if every step in the chain, so you have the encoder, which makes the files, you have the origin, which catches the files from the encoder, you have the CDN, which takes the files from the origin and moves them closer to the viewer. If each of those takes full ownership of an entire file, you're basically stacking that latency as you go. And then, of course, the player, because it wants to deliver a fluid experience, is going to conservatively buffer a few of those segments. And so it gets to be kind of gross, because all of those latencies add up.
Gross meaning big.
Yes, you get a very large latency. You get smooth playback, which is probably the right trade-off to make. Yeah. But the truth is, all the fundamentals of distributing data over the internet have gotten so much better that we need different workflows now. So the advancement here is to use a system where each segment is broken down into what are called individual chunks. And a segment is written chunk by chunk by chunk. And the key thing is that each step is pushing it to the next step in the chain on these chunk boundaries. And these chunks might be only 4 frames long, so incredibly brief, less than 100 milliseconds or something like that. And we have an amazing, totally accurate video explainer for how this works here. So we're going to side by side show the segment-based model and the chunk-based model here. So here we go. So on the top, we'll show the new style chunk transfer encoding, and on the bottom, we'll show the traditional style. So this is totally accurate here. There they go, and they're off. Oh my gosh, you can see that just by delivering chunk by chunk from the top through the chain, that content gets there so much faster than if you force an entire segment to be full at each step. So, great technology. And where we've made significant improvements here in the AWS product suite is in our live encoder. So Elemental Live supports this technology. In our origin service, so Media Store now supports this technology. You can push a segment and ask it to pass it through, basically make it available to the output as it's still coming in on the input. And then CloudFront, the Amazon CDN, also supports this technology. And
do we think this is production ready now? Because this is something that's been talked about for a while, and like all technologies, it usually comes out, it's in the news, and then it needs to percolate for a while before it's actually ready for production. So
that's true. So that is typically the broadcast technology flow. There is a percolation period, but at this point, percolation is complete, and customers have been very successful using this in production. So our customer Fuji TV did a ultra low latency live production of a volleyball event, the FIVB Volleyball World Cup. I myself missed it, but I hear it was very popular. And you can see it's exactly that problem that we framed at the beginning of this dialogue. There existed a broadcast path. That broadcast path was very mature. The latency on that broadcast path was good, but they also wanted to serve web browsers, phones, tablets, things like that through OTT, and they needed that latency to be low. They were using a partner encoder, an AWS Elemental Partner Network company named Videon, and they used Direct Connect, they used Media Store, and they used CloudFront, and they were able to achieve incredible results.
And for them, they had kind of 2 different workflows that they were going through. One was a alternate broadcast, so you could watch the same thing on your traditional TV or broadcast, or you could watch the other path on your devices. But they also were doing a second screen type of view, so that you could set them up side by side, and you could have alternate angles of the court and what was happening, and have that kind of deeper engagement with customers.
Yes, that is such a great point, right? OTT, why do people watch OTT? OTT isn't just watching television on your tablet. OTT gives greater capabilities because of that greater horizontal scaling. So our customer, Fuji TV, they have to make a decision what one program goes out on the broadcast moment by moment, what one camera shot goes out. But in the world of OTT, they can actually scale out horizontally, make all the camera shots available, and the end customer gets to decide. So that's great. And then you may ask, well, low latency is great. How low was it? Well, using a very sophisticated two pieces of software, one, the camera app on your phone, and two, the calculator app on your phone, we were able to confirm, this is actually from the venue here, that they were able to achieve 2.56 seconds of latency. So, this is a fairly simple technique. You point a camera at a clock, you look at when the answers become available in your mobile player, and you simply subtract, and that tells you the overall latency. So, you might hear this called glass-to-glass latency, right? It's the glass of the camera lens, and then it's the glass of the player. You had asked, is this production ready? There's actually two other features we can add on top of this that are fully supported by this ultra-low latency workflow. And the first is DRM support. So this is available in the Elemental Live product. Elemental Live has a pretty rich DRM support, including using the AWS Speak API to talk to a variety and ever-growing list of DRM server providers. And then lastly, this workflow is compatible with server-side ad insertion through our Media Tailor server-side ad insertion product. So not only can you deliver this content, you can protect this content so it's only available to your paid subscribers. Or if you're doing more of an ad-supported workflow, you can pair it with server-side ad insertion. Mm-hmm. So not only can you deliver a great experience, but you can actually make money on these experiences as well.
Yeah, that's kind of the percolation that I was talking about, where it goes from a technology that's used for free over-the-air broadcast or free over-the-top broadcasts to technology that can be used for premium channels with DRM and ads inserted as well.
Absolutely. Okay, so that's ultra-low latency.
Awesome.
So next we're going to talk about AWS media-specific tools. Mike, what should our viewers know about this?
So for this, one of the real keys here is that AWS has been building products that are specifically for media workloads. And so we have a good set of examples of things that are for media workloads that are feature enhancements in this upcoming section in our theme 5. These are existing products that we're adding new capabilities and technologies onto. So that is one of the key pieces, and this is extensions of the existing products, but for media. So as we go through them, we'll talk kind of a one slide overview, and then a little bit more depth on a couple more.
So as Mike points out, the existing AWS services continue to add features and capabilities. And this is really just a snapshot of some of the things that have come out in our existing services in just the last few months. Really, if you want to dive into any of these, we recommend the AWS What's New pages, which have a special section that you can filter down to just media and entertainment related feature launches. So we've had a number of releases that are meaningful for media and entertainment customers. We've had them in the AI and ML products. Mike will say a little bit more about that in a moment here. Global Accelerator continues to add capability to help make to help our customers get their content onto the AWS network closer to the end customer. S3, our storage system, continues to add features. And then, of course, the media services. We have features in media services related to input failover. We have features in media package related to manifest filtering, so you can tune the delivery per device type that you're sending content to. Media Store is now fully integrated with CloudWatch, so you can build dashboards that show the health of your entire streaming solution. And then Media Convert now offers HDR to SDR tone mapping. So from a single HDR master, you can deliver content to both HDR and SDR players. Really, there's just a whole set of capabilities that have been released across the existing AWS products. And Mike is going to dive in and say a little bit about what we've done specifically in machine learning and content recognition.
Yeah, there's a couple more. So Rekognition has rolled out a couple of features recently. One is custom labels. And this is a way so that you don't have to be a data scientist in order to be able to have a machine learning product check for specific types of elements within your content. So in this case, we're highlighting cucumber leaves, and you can have a very simple way through custom labels to have cucumber leaves be identified as damaged or with white mildew on them or as being healthy, and have this run against your entire library. This could be, in the case of the Rock and Roll Hall of Fame we talked about earlier, this could be types of guitars or brands of guitars, for example. And you can do this now without being a data scientist. The second piece of this is, or the second feature that Rekognition has rolled out is one around compliance and quality control. So this is useful if you have a library that you are receiving from somebody else, for example, and you want to check to make sure that there is no content that is violent or visually disturbing or has nudity or is suggestive in it. And this is useful for many of our customers in the case of a company who is receiving advertising content that they are then going to send out to their customers. It's useful to run the advertising pieces that you're receiving in to make sure that it doesn't have anything that would be in violation of federal laws or issues that you would normally try to filter out. And the same thing could be true for a company who is trying to create content for multiple regions around the world, where many of these may be blocked in one way or another, or not allowed to be broadcast.
So those sound like some great capabilities. Another area in which media and entertainment customers are always interested in is what's new in the world of codecs. Codecs being how we package up content and then deliver it to customers efficiently and at high quality. And of course, the codec that's on everybody's mind lately is the AV1 codec. So what's new in our support for AV1?
Yeah, and with AV1, a little while ago, Media Convert rolled out their ability to encode AV1 as part of their standard product. So AV1 is part of the standard product for Media Convert today and is compatible with accelerated transcoding. And what that means is that you can take your AV1 encode and spread it across a lot of many different instances in order to have the overall processing time be reduced. And this has traditionally been a big challenge for all new video codec development, test, development, and deployment, actually. Because what would typically happen is you would create, as the new video codecs were being tested, they would run at 1 frame every 5 minutes or something like this, very, very, very slow. But with the power of the cloud and the ability to run many of those encodes simultaneously, you can overcome a lot of those limitations and get to a point where you can process these new codecs basically in real time.
So a customer today can take a mezzanine asset, use Media Convert, and build AV1 video codec outputs that are suitable for distribution today.
Yep, exactly. And I mean, AV1 is starting to show up in web browsers, and eventually, or soon, it will show up across devices as well.
Wow, that's great. So we've talked a little bit about what we've done with our existing products, but what new products and new technology launches do we have to cover this season?
In addition to those kind of feature enhancements on existing products, now we're also going to talk about some of the new technology products that are just coming out now.
Great.
So this one is the Media Event Management product, and this is really a AWS support product, or an AWS Elemental Support product. And what it is the ability to have somebody, a support team from AWS Elemental help with your new product launches or your events. So the support team is able to apply all of the knowledge and experience that they've learned from running many, many events and apply those to your video workloads. And those video workloads could be running on media services, or they could include AWS Elemental appliances, or both. But that is the main focus of this team and this program, is to help customers from the very beginning of discovering kind of what their workload looks like, how has the support team seen other workloads that were similar work where the issues come up, run through operational readiness and testing with event preparation to make sure that the events are going to go off with as few of unknowns as possible. And then moving over into support and having the AWS folks in your war room with you in case something goes wrong, so that this expedites the service team work and engagement.
Wow. So as a customer, I can retain AWS Elemental specialist resources, specialist people who really know this stuff, who have done it before. They'll do a sort of pre-flight check. They'll work with me on developing a plan for the event, and they'll even participate in my war room during the event to make sure that everything works well. And it covers the on-prem devices all the way through the media services. So I'm getting support basically from my SDI port all the way through my CDN through to the player.
Exactly.
Wow, that's a great offering. That's very exciting.
Exactly. The next one here is over for you for AWS Elemental Link.
Right, so AWS Elemental Link is something that my team worked on, and we're very excited about it. So customers have been coming to us for a long time, and they've had lots of problems in sort of distribution encoding and CDNs and origin servers and all of these things. And for many years, we've provided a lot of capability there. But what we started to hear from our customers was this theme that getting live signal from the venues where these interesting things were happening and getting it connected to the cloud so you could access all of those great distribution, encoding, and origination technologies was actually quite a challenge. In the worst case, you had to source and buy devices from a vendor. You might have to do some compatibility, not just things like, is the video compatible, but is all the audio working together correctly? Does it support closed captioning? If I have ad markers in the content, is that going through? If I want to push timecode, is that going through? All of these little compatibility details that had to be checked. There were, in some cases, the good devices that you could rely on were too expensive. Or maybe the ones that had great VQ were too large. And in many cases, it just came down to the availability to sort of put human talent on the problem. If you were sourcing content from your main broadcast facilities in, say, New York or Los Angeles or a media hub like that around the world, it was fairly easy to get an expert kind of pointed at that device and solving problems and getting it configured right. And you could be confident that you were handling all the security correctly and things like that, and that you had really built a well-architected premises to cloud contribution system. But the problem was, as you sort of proliferated and you wanted to access more and more venues, let's say you wanted to access a bunch of houses of worship, or you wanted to access a bunch of education environments, or you wanted to access say, city and local government things, or you wanted to access, kind of lower tier sporting events. In all of these cases, it became so difficult to get your talent in a position to configure each of those devices. And so those customers that were able to succeed here ended up doing a lot of undifferentiated heavy lifting and building these solutions where they could kind of like get devices, send them places, and provision them remotely. So what we decided we would do is that we would create a product that helped our customers solve all these problems. And so that product is AWS Elemental Link, and I happen to have one right here. So AWS Elemental Link is a small, low power, low cost, but high quality and very secure on-premise link to the cloud. So it has ports on the back here. Very simple connectivity. You provide internet connectivity and you provide live video in either the HDMI or SDI ports. And then it has this locking power supply connector here. And in fact, if 3 wires is too much for you, it even supports power over Ethernet. So in as little as 2 wires, you can connect your live video to the cloud using this device. It connects to the cloud using DHCP, or has a sort of onboard user interface if you need to set it all statically. And the beauty of it is you've bought this thing through the AWS console. So it comes pre-configured to connect securely to your account. All of the encryption secrets are pre-shared and pre-loaded on the device. So you don't have to do anything. You just bring it to your environment, you plug it in, you turn it on, the lights in the front go blue, and you're ready to go. And what that means is from that moment forward, all of the monitoring, status, and control you can do from the AWS console or through the APIs. Here's that diagram in a little more detail. So you can see that Elemental Link, the piece in the solid orange box there, is really part and parcel with the Media Live service. It's automatically provisioned and automatically connects to the AWS console. Every one of your devices shows up in the Media Live console and the API as a device ready to go. You could pull thumbnails and status information. Is the signal connected? What format is it? Is there audio? Is there not audio? What thumbnail is on the video right now? You can pull all of that through the API, which means not only is this a good solution for one venue, but it's a good solution for hundreds or even thousands of venues. You can have a whole fleet of these distributed throughout the world, and using the AWS Media Live API, you can keep track of all of those ports, and you can reliably build live streaming experiences using them. Everything is secure. The control plane is secure. Using those pre-shared keys, the data plane is secure. Your device can only send live content to your account, and no one else's device can send content directly to your account. There's a couple of other advanced video features in here. We're using the most advanced video codecs to get the best quality given the bandwidth out of the venue. And the other thing we really heard from customers about venue bandwidth is it's unreliable. In many cases, you'll pay a network engineer to work on your headquarters bandwidth, but you won't have that guarantee out at a venue. So they really needed flexible solutions. And so we built into the Media Live service and into the Link device, we built intelligence to monitor the quality of that internet connection and to modulate the encoding bandwidth used to send the signal up to the cloud to match the conditions. So you'll never get blocky signal or breakup or just a total failure to stream. If necessary, the device will reduce the bandwidth consumed, so it's always getting the best possible picture out of that venue. And then lastly, we invested in a lot of those kind of advanced differentiating features like closed caption support, timecode support, ad marker support. So it really is a product that stands head and shoulders above others in terms of its capabilities, but also its simplicity. So we're very proud of this, and we think our customers are going to build some really amazing solutions out of this thing. Of course, to really kind of complete the story here, we're going to hand over to Matt Vegas. So Matt Vegas is the product manager for AWS Elemental Link, and he's going to take us through a live demo of this. So he'll show you just how easy it is to get up and streaming using one of these devices.
I'm Matt Vegas, Senior Product Manager for Amazon Web Services. Today we're going to show you our new product, AWS Elemental Link, and how easy it is to set it up. All you got to do is plug in power, SDI. It'll also take HDMI as an input and Ethernet. And the device comes pre-configured to your Amazon account. It's going to automatically build up a video stream, automatically connect to Media Live, and start sending video. In Media Live, in the console, I have a channel all set up and ready to go. Once the device connects to Media Live, it'll just start streaming right away. Right now, the connection state is showing as disconnected as it builds up a connection to the device. And we should see in a couple seconds here, it'll connect. All right, now we're connected. The device is streaming. So we're going to go to Media Package, where I've set up a CloudFront URL as our CDN. I'm going to pull up this QR code and scan it with my phone. And what you're going to see here is, in just a couple minutes, we've set up a live video stream. So that's how easy it is. Thank you, and back to you guys.
Excellent. Thank you, Matt, for walking us through how easy it is to use the AWS Elemental Link. It is, I think, going to be a great piece of technology for sports venues, houses of worship, et cetera, to really be able to get high-quality video out in a new and interesting way. Moving on to kind of our wrapping up what we've talked about today. We've walked through our themes for NAB 2020, including that AWS is the place for media, starting with the technology Emmy, or the Technical Emmy Award, along with the set of partners who are doing really interesting things within the media space. And we've shown how we're bringing the cloud closer to you through local zones and outposts, for example, as well as virtual workstations. Kevin walked through how broadcast is moving to the cloud, and really where we see the vision of broadcast in the cloud going. We talked a little bit about ultra-low latency streaming, how the world has changed, and how this is actually becoming production-capable technology instead of technology demos. And then finally, through the AWS media-specific tools, so the enhancements to the existing products, and of course, the latest service launches that we just talked through. Coming up at the end of May is the AWS Insights online conference. So in addition to all of the reference area from this webcast, where you can read about almost all of the things that we just talked about, we'll also go into more detail with 30-minute sessions for most of them throughout the Insights online conference later at the end of May. So thank you very much for attending, and thank you, Kevin, for taking the time to walk through all of the technology that you did.
Yes, thank you very much. It was my pleasure.
Thank you.